Welcome to today's deep dive. So imagine you are standing in front of a massive video wall at a sports bar. Every screen is perfectly synced, showing flawless 4K video.
It looks like magic, honestly.
Right. But what you don't see is this frantic, microscopic light show happening right behind the drywall to keep that image from collapsing into a pixelated mess.
Yeah, it's an invisible infrastructure we all interact with constantly, but we're usually completely unaware of the heavy lifting going on.
Totally. And today we are analyzing a technical product sheet from HDTV Supply for the Avenview 4K DisplayPort extender. Our mission is to decode how massive amounts of visual data travel over long distances without degrading and, why understanding this invisible tech infrastructure actually matters to you.
It really is fascinating when you get into the physical mechanics of it.
Okay, let's unpack this. Sending high-quality 4K video over long distances, it's kind of like trying to whisper a complex secret across a crowded stadium.
Right, eventually the message just, completely falls apart.
Exactly. But the Avenview extender solves this. It pushes true 4K resolution, so that's 4096 by 2160, at 60 Hz at data rates of 5.4 gigabits per second up to 49.2 feet, or about 15 meters.
Which is just a massive amount of dense data.
It is. But wait, let me play devil's advocate here. Why can't I just string together a bunch of cheap standard cables from the store to reach 50 feet? Like, why have the specialized hardware?
That is the exact trap a lot of people fall into. Well, what's fascinating here is that traditional copper cables suffer from strict physical limitation.
Oh, like electrical resistance and stuff.
Exactly. Electrical resistance and electromagnetic interference. The longer the copper wire, the more the electrons carrying your data get scrambled by outside magnetic fields.
Right, so pushing a huge fire hose of data over a short distance is fine, but
trying to force that 5.4 gigabit stream through 50 feet of standard copper is like trying to blast a fire hose through a leaky garden hose.
so the signal integrity is just destroyed by the time it reaches the end.
Yeah, entirely destroyed. So to fix this, the system relies on a unique hybrid multi-mode optical fiber and copper structure.
Wait, fiber optic, so it's using light.
Yes. To prevent data drop-off, the transmitter unit physically converts the raw DisplayPort signal into pulses of light.
Oh, wow. Because light obviously doesn't suffer from electrical resistance.
Right. Photons can travel through fiber optic cables completely immune to the magnetic fields emitted by other cables in a wall. It preserves the exact integrity of the stream over the full 49.2 feet.
Okay, but here's where it gets really interesting. My TV doesn't have a fiber optic port. A monitor expects a standard electronic signal. So how does the screen actually read that light?
Well, that's where the specialized receiver unit comes in at the end of the line. Think of it like a brilliant real-time diplomat.
A diplomat.
Yeah, it instantly decodes the optical data and automatically adjusts the output to perfectly match the display's specific resolution.
Wait, so it's not just a dumb translation, it's actively communicating.
Exactly. It's a constant high-speed hardware handshake happening completely out of sight.
So what does this all mean for you, the listener? Because looking at the spec sheet, this has a price tag of $999.
Yeah, it is definitely not your average living room cord.
Definitely not. Plus, this unit is rated to operate in temperatures up to 122 degrees Fahrenheit.
Which is crucial context, actually, because enterprise AV racks get incredibly hot. A standard consumer-grade cable would literally melt down under that thermal load.
Wow, so it represents the bulletproof, invisible backbone powering the massive, flawless video walls and sports bar screens you encounter daily.
Exactly. If we connect this to the bigger picture, it illustrates the incredible unseen engineering required to deliver the seamless visual experiences modern consumers simply take for granted.
We just expect it to look perfect.
Right, totally unaware of the high-speed optical translations and extreme thermal resilience required right behind the drywall.
It really makes you rethink the physical spaces we walk through. And we want to leave you to ponder this. As our displays inevitably push past 4K into incredibly data-heavy 8K territories, will traditional copper wires completely vanish from our homes?
That's a great question.
Are we rapidly moving toward a future where our entire digital existence depends entirely on microscopic beams of light?